Hi everybody, very good evening and a warm welcome to Vedantu JEE English. Yes, we changed the name, isn't it? Vedantu JEE English, and this is your Master Teacher Nabamita Mam. So what's up? How are you all? I'm really sorry. Initially, I'm really sorry that I had to time and again reschedule this class because to be very honest, I was absolutely unwell. I had 102-degree fever for 3 to 4 days. Had to go to the doctor, get myself checked, and blah blah blah. All of that happened, and now finally I am all right. So quickly go and call up your friends, everybody. Let's begin with the class. Come on. Go ahead, guys. Hello Harini, welcome. How are you? All good? Quickly go and call up your friends, everybody. Let's begin with S block today. We're going to complete S block. No, not complete. We're going to do half of S block. Yes. And then we will move ahead with the second half tomorrow. Okay. Tomorrow 5 p.m. again, everyone. Yes. Do I have all my students here? Not yet. Guys, come on. Quickly call up your friends. Hello. Hi, World of Nosy. Hello. You have a test in S block. Amazing. Hi, Alvin. Hi, Vardhan. Hello, everybody. Yes, so I was all this while, I was talking to myself and I realized, and I was just telling you all that I was very unwell. I had 102-degree fever for, 3 to 4 days, and that's why I couldn't take class. I'm so sorry. But now I'm better. I just have a little bit of cough and cold, but that's manageable. Hi Raghavan, hi Irfan, hi Free Fire, hi Pavan. Very good evening, everybody. I'm fine now. Yes, thank you so much. But thank you so much for your concern. Yes. So how are you all doing? Are you all fine? Hi Arjunan. Hi Vanga. Hello. Very good evening, guys. And in this while I was not doing well, the channel name got changed. This is JEE English, and this is your official JEE English channel, everybody. Yes, and everything is going to be in English only. Yes, you are from, okay, how many marks to get seat in JEE? You will get to know about all of that. Yeah, that actually every year it changes. It depends on how many students are appearing, and it depends on what is the top rank. From there it's calculated. Okay, so you can't really say that how many marks, but you keep watching Shreyas sir's video. He keeps telling about it. Yes, and Shimon sir, they keep talking about these kind of things. So don't worry about it, but I will definitely talk about it. You are prepared for NEET. Very good. Raghavan, I'm better now. Hi Ramu. Hello. Very good evening, guys. Okay, let's start. So today we are going to start with S block, inorganic chemistry. It's written as one shot, but this is one shot part 1. Okay. All right, everybody. So let's begin, everyone. Let's start with it. Namaste. Hello, optimal learning with VR. Okay. Yes. So now that you are here, don't forget to like the video and don't forget to subscribe to the channel. As you know, this is your JEE English, an official channel for JEE information completely in English. Yes. How will advance, ma'am, how will advance be tougher in inorganic? We will talk about it. Don't worry. My health is better, Harini. Thank you so much, bacha. Thank you so much. Yeah. So let's begin, everybody. You're fully confused. Don't be. It's okay. We are here. Don't worry. Okay. So everybody sit with a notebook and a pen so that we can write down the notes. Yes, and also I will be giving it to you. I have made a folder where I have collected all my notes that I have taken in different studios, and will be sending it to you very soon. Walaikum Assalam, Wasim Latif. Walaikum Assalam. Okay. So now you all know my name is Nabamita Bhattacharjee and I am your JEE Chemistry Master Teacher. Yes, will you revise organic chemistry? Yes, I will. Very soon we will start with organic as well. First let's complete inorganic and then we will jump to organic. Okay, I know that Wasim sir has been taking you through physical chemistry a lot, but he does not really have much time for organic. So I will be stepping in and I will be taking care of your organic chemistry as well. So now S block, when we talk about S block, we can only imagine the periodic table, isn't it? And in the periodic table, the first 2 groups are your S block, isn't it? And you know what? With love, what do we call the S block elements? The first group is called as alkyl alkali metals, and the second group is called as alkaline earth metals, everybody. Yes, when will be JEE 2023? We'll talk about that, bacha. Right now, please concentrate on S block, okay? Everybody, come on. Guys, can I have your full focus here? I want your full focus here, everybody. English, yes, English JEE class. Come on. Alright, let's start. So, when we start with S block, you know what? Let's take a blank slide here. Let's take a, I don't have a blank slide. Okay. So, when we talk about S block, everybody, please write it down and listen to me. S block has two groups, group 1 and group 2. Every time you look at the periodic table, the first two groups are your S block, and the first two groups, they are also named with love. Yes, with love we have given them alkali metals and alkaline earth metals. That's the name, isn't it? Yes. Now, as you see that these alkali metals, do you know what do? They form hydroxide on reaction with water. So, the question that might come in your exam or come in your head is, why are they called as alkali metals? Why? How do you see that? How do you find them alkali? Do you find them alkali? Do they look like they are alkali? Actually, yes. When they react with water, they usually form their hydroxide, and of course, if they form hydroxide, that means they are alkaline in nature. Sodium hydroxide, potassium hydroxide, lithium hydroxide, all of them are alkaline in nature. So, that is why alkali metals, alright, and they are strongly alkaline in nature. It's not like, you know, they're like, okay, 7, 8, 7.5 in the pH scale and 8.5 in the pH scale. No, they are actually strongly alkaline in nature. Are you understanding? Yes, everybody? Getting it, my dear student? Is this clear that they are strongly alkaline in nature and these are known as alkali metals? Now, how do you remember it? So, this remembering trick is actually in Hindi. Yes, we say that Leena ke rab se faryad, okay? Leena ke rab se faryad, or you can just write, or you can just remember it as Leena ke RBCS, okay? Leena ke RBCS, just say that once again and again, you will be able to remember it, okay? Leena ke RBCS, that is lithium, sodium, potassium, rubidium, cesium. Now, francium is slightly radioactive, so we don't have to talk about it so much. Yes, is this clear, everybody? Moving on from here, now you all know that, remember in periodic properties we learned that as you go towards the right, what happens? Atomic size reduces. That means that these guys, this Leena ke RBCS, they have the biggest size, of course, except noble gases. Noble gases are already bigger, right? Noble gases are already bigger, so we're not going to talk about it, but we know that these are the largest in their period. Apart from noble gases are the largest. Apart from noble gases, these guys are the biggest, okay? These guys are the biggest. English tricks, Leena ke RBCS, Leena ke RBCS. Just keep saying that. Law rules channel, Leena ke RBCS. Well, let me find it out. Once I find it out, I'll tell you what is the English tricks also. But till now, I haven't found out. And you know what? I actually studied in a KV, right? I studied in Kendriya Vidyalayas, and Kendriya Vidyalayas are predominantly Hindi. So, most of our teachers were North Indians and they kept talking to us about all of these only. So, this is how I learned it. But for you, I will definitely find out an English way to learn this, and I will find it out. I'll tell you that, okay? Alright, everybody? Yes? Chalo. Now, moving on. So, what do we know? Periodic properties is the godfather of whole inorganic chemistry, my dear students. And in periodic properties, we know that as you go down the group, the size increases. So, don't you think that this is what will happen here also? Yes? Don't you think that this is what will happen here also? Of course it does. Of course it does. When you go down the group, as you move down the group from lithium to cesium, yes, from lithium to cesium, you will see that the size increases. The size increases here as well. So, lithium has the smallest size in this group and cesium has the biggest size in this group, okay? So, size increases from Li to Cl and Li to Cs. Why? More number of electrons are adding up, more number of shells are adding up, right? K, L, M, N, it is increasing. So, obviously, here you see that Cs has the highest size. Is this understood? This is clear, everybody? Quickly write down la 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 if you are understanding this, everybody. Quickly write down la 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 if you are understanding this, everybody. And also, please call up your friends. Why don't I see more of your friends? Yes, it's 8:30. Come on. S block also has a great number of, you know, last to last year, I think NEET had 8 marks from S block, and I also told you about the weightage of this, right? S block is kind of important, my dear students, so don't forget it, okay? Don't forget it. Anyway, moving on. Yes, hi Vetrimaran, how are you? Hello. We are not doing Tamil here, we are doing it in English, okay? We are learning it in English here, yes. Shimon sir is not here. This is not Shimon sir's class. This is Nabamita Mam's class. This lesson will, yes, this lesson will also have a part 2, bacha, okay? This lesson will also have a part 2. I don't want you to, everything goes bouncer on top of the head. I want you to understand while I'm teaching you, yeah? Chalo, moving on. Now let's talk about melting and boiling point. What do you think? Acha, everybody, before I move forward anywhere else, do you know what is the general electronic configuration? What is the general electronic configuration? Their general electronic configuration is NS1. That means that valence electron is only one. There is only one electron at the last shell. That means for them it will be very easy to give away the last electron and attain their what? Noble gas configuration, isn't it? So if there is only one electron, in the outermost shell, now do you understand that they are going to form really weak bonds? Just one electron, that's it, one electron. The bond is going to be weak, isn't it? The bond is going to be absolutely weak. So that means we understand that weak interatomic bonds are due to their large atomic radii, plus the atomic radii is also huge. Now tell me, if I have a long pencil, will I be able to break it easily? Yes, I can break it. But what if I have this chottu pencil, will I be able to break it? Very tough. Very tight. Even to sharpen it, you really have to use up all your strength and sharpen, isn't it? Tell me something. Yes? Have you used a very small pencil? Hi Madhu Reddy, welcome. You must have noticed that, right? If you have a long pencil, chalk, and you're done. But if you have a small pencil, like, you have to do it and then you have to like sharpen it. And also to break that apart, you will not be able to. You can't even bite it with your teeth and break it because it's that strong. So now tell me something, if the bond length is smaller, do you understand that it is going to be very tough to break it? But if the bond length is bigger, you can very easily you can break it. Now these fellows, the group 1, the G1 fellows, you understand that they have big size. If they have big size, that means the bond is also going to be long, right? If the bond is also long, then don't you think that you can easily break it? And if you can easily break it, that means that the bond is weak. That means that the melting point and the boiling point are going to be low because you can easily break it. Yes, you can easily melt it, you can easily boil it. What say they get boiled, right? Yes, everybody, understanding the session will end at 9:30, sweetheart, okay? 9:30. Hello, Nisha, welcome. Okay, so weak interatomic bonds are due to their large atomic radii and the presence of only one valence electron, and that is why their melting point and boiling point are low. So right now we are talking about without part 2. Yes, no, tomorrow we have part 2, everybody. I initially thought I'll be able to complete the whole session at one go, but I don't want to do that because I want you all to, I want to make sure that everybody understands the session first. So I'm going to take it bits and pieces, okay? In 2 sessions I'll be completing as block. After that we will be doing the important questions, okay? In between I also have to start with AM set. EM set questions are also very important. You have to attempt that exam as well, right? So in between I will also start with EM set, and after completing the whole of inorganic we will jump to organic because I know that physical chemistry is being taken care by Wasim sir very well, isn't it? So we will jump to organic chemistry. Cool? Okay, moving on everybody, listen to this. Yes, periodic table lecture. I actually have already, yes, 2 chapters. I started with periodic properties, but anyhow don't worry, I'll take more, okay? I'll take more. Chalo. Alright everybody, now decreasing order of melting point and boiling point once again. What is going to be the decreasing order? Don't you think that as you go down the group, the size increases, so melting point and boiling point will decrease. Size increases, melting point, boiling point will decrease. So can we understand that melting point and boiling point are inversely proportional to the size? The size increases, they decrease. Size increases, they decrease. So you can see that CS has the lowest melting point in the group. Am I clear here everybody? Is this clear everyone? Got it? Clear? These are all physical properties. Right now we are only at physical properties, okay? Moving on. What about ionization energy? You tell me, my dear student, what was ionization energy? Once again everybody, coming to the definition of ionization energy, we know that ionization energy is basically taking one electron from the atom. How easy is it to take away one electron? That's your ionization energy. Basically, the energy that is given to the atom to take one electron away, that's your ionization energy. Now tell me something. These guys, these fellows, the group 1 guys, they have 1 electron. They are anyway overly excited to give it away. They're like, take it, man, take it. We want to attain our noble gas anyway, right? We want to attain our noble gas configuration. You know what? You take it and go. Just take it and go. So they are easily able to give away their 1 electron. So that means that the first ionization energy, and you know that ionization energy is what? First ionization energy, second ionization energy, third ionization energy, isn't it? So can we understand that the first ionization energy is going to be very little, very less, because 1 electron they can easily give away. But once they have given 1 electron away, here is a comparison, everybody. Here is a comparison between group 1 and group 2. Understand this, okay? Now, group 1 can give away 1 electron very easily, but after that, they have already attained their noble gas configuration. Now, if somebody asks them, okay, 1 more electron you give, no, they will be like, you know what? I'm very happy. I'm not going to give away anything. This is mine. This is all mine. This is all mine. This is my asset. They are not going to give it away. But talk about group 2 now. Group 2 has 2 electrons in their valence shell, right? So 1 electron it can give away. But that first ionization energy is going to be slightly higher than them. Second ionization energy will be very little, because then they can easily and readily they can give away the second energy. They can readily and easily give away the second electron, because that time once they give it away, they are going to attain noble gas configuration. Is that right? Is that right? Do you understand the comparison here, everybody? Are we understanding the comparison? Come on, I need some la in the chat box, some interaction, everybody. One shot. I am. Physical chemistry is being taken care by Wasim sir, bacha. So I'm not gonna do that. Yes, I'm not gonna do that. I will be starting with organic chemistry after inorganic. And I know that inorganic is really dry. So let's talk about this. Thank you, Vedantu student Ravi Kumar. Thank you so much. So do we understand this, everybody? Yes? First ionization energy for group 1 is going to be very little, but second, this time they know already that, hey, we are stable. We are stable. We are stable. You tell me, mostly, have you seen that once people get married, right? Once people get married, you can't just call the wife or the husband. You will have to call both of them, right? You'll have to call both of them. Because for them to leave the other one and come, no, they're not going to do that, right? The same way here also, they have already given away. Already they gave away 1 electron, but after that, now that they have achieved their noble gas configuration, it's going to be very hard, because they don't want to get away from that stable life. They are very happy. They're stable now in their life. Finally, they are stable in their life after giving 1 away, right? So they're like, no, we're not going to give it away. So second ionization energy will be very high. Second ionization energy will be very high. Now, what is the decreasing order of ionization energy? Tell me. Okay. In the group, what will happen to the ionization energy? Please tell me. Think about it, everybody. In the group, top to bottom, what will happen to the ionization energy? It will decrease. Why? Because the size increases. If the size increases, it becomes even easier. Isn't it? So yes, absolutely. Ionization energy or ionization enthalpy decreases down the group, okay? Decreases down the group as the size is increasing. But like I just told you, just read it from here. I have told you, I have already explained that second ionization energy of alkali metals is going to be very high, because by losing 1 electron, they achieve already inert gas configuration, and after that they are not going to give away their most lovable state, that is their stable state. Yes, good. Can GOC session? No, bacha. GOC sessions this week will be difficult, because this week we have already planned for EM set. We have already planned for fantastic 5 sessions. Yes, where we will be doing JEE advanced questions. Okay. We will be doing 5 JEE advanced questions that we teach in Vedantu's platform. We will be doing this, and I have 3 sessions per week. So it will be very difficult to start with GOC, but let us complete inorganic first. Then we will go for organic. Okay. Uma, I'm so sorry, but physical chemistry class timings, I don't have it. You will have to ask Wasim sir because he takes care of it. And I am not very sure about when he takes classes, okay? When he takes classes, I do not know about it. Anyway, you were waiting for this session. I'm so sorry, I was unwell. I was not well for quite some time, but finally I am well. And I'm taking the class. I'll tell you about my timings, no? I'll tell you about my timetable. Don't worry. I am so sorry, Harini. I got, viral fever and 102 fever. I couldn't even get my head up from the bed. It was a horrible time I spent, and I really did not like, I don't like being sick. Yeah, I don't like being sick. It's just too boring. But anyhow, finally I'm better. Please tell postulates. Murugan, there are no postulates right here, okay? This is all facts, fact-based, this thing. But anyway, if you want, you can write down my timetable. Please write down my timetable, okay? Everybody write down Monday 8:30. Monday 8:30 p.m. okay? Friday 8:30 p.m. Alright, and Saturday 5 p.m. Saturday 5 p.m. This is my timetable. 3 sessions. You have exam on this chapter, okay. Referral and predictions, thank you so much, thank you so much. This is my timetable, write it down, okay? Write it down. Now, let's move ahead, everybody. Mr. IITN, hi, hello, welcome. Okay, let's move ahead. Now, what is electropositivity? What is electropositivity? Any idea? What is electropositivity? Very easy, yeah. Electropositivity is basically an atom's tendency to lose electron and have positive charge. That's it, right? An atom's tendency to lose one electron. So you understand, see, if an atom gains electron, then it is what? Then it has negative charge. It gains negative charge, isn't it? It gains negative charge. Why does it gain negative charge? Because more electrons have negative charge. So negative charge. But if an atom gives away electrons, then it has more number of protons, and protons have a positive charge. So that is what is your electropositivity. That is what is your electropositivity. Yes. So if there is a larger size atom, then its tendency to give away the electron will be, of course, very much. It will be highly dedicated, like, okay, please take one electron from me. And these guys, they anyway have one valency, so they are like absolutely waiting and excited to give away their electron, right? They are absolutely waiting to give away their electron, yes? Because they want to attain stability. So you understand that due to their larger size, the electron, it can be easily removed and they can form M plus ion. How are they forming M plus ion? Because they gave away one electron, they have more number of positive charge, so they become M plus ion. So electropositivity, it increases from lithium to cesium. Why? Because we know that down the group the size is increasing, their tendency to give away electron is more, right? They are not gaining, they are giving away electrons. And also understand this, that electropositivity is inversely proportional to ionization energy. Of course. The lesser is the ionization energy, more is the electropositivity. Yes, because the less amount of energy you have to give to take out the electron, more is the electropositivity. Of course, right? So this is what is explained here. This is what is written here. Very easy. Very easy. Now let's understand density. So we all know that density is directly proportional to mass. Mass increases, density increases. But what about volume? What about volume? Yes. Volume increases, density decreases. Yes, volume increases, density decreases. But volume decreases, density increases. So that means that density is inversely proportional to volume, but it is directly proportional to mass. So in a group, atomic volume increases. Right? In a group, atomic volume increases along with atomic weight, but atomic weight increases more than atomic volume. So what happens? Density increases from lithium to cesium, because obviously in cesium what is happening? The volume is also increasing, no Baba? Yes. Mass is increasing, definitely. Mass is increasing. But more than mass, their size is increasing. So that means that volume increases more, isn't it? So that means that volume increases more, and if volume increases, we know that density will decrease. So here, what is predominantly acting? predominantly the volume part acts up more, and that is why we see that density is decreasing. Okay, that is why we see that density, that is why we see that density increases, because volume, what did I say? Sorry, density increases from lithium to cesium because we also see that mass is increasing. Atomic weight is mass is increasing, right? But atomic weight increases more than atomic volume. I'm so sorry, I said it ulta. Yes, here predominantly mass is acting up. The whatever I said right now, that actually acts up with group 2, okay, that adds up on group 2. So understand this, everybody. Here we know that although volume is increasing, yes, although volume is increasing, but more than that, mass increases, and because mass increases, density also increases. So this is the increasing order of density here. Okay, lithium has the least density and cesium has the highest density. Do we understand this, everybody? Are we clear with density? Are we clear with density, everybody? Can I get some la 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 in the chat box? Can I get some la 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 in the chat box, everybody? Yes? Come on, guys. I need some la 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 in the chat box. Go, go, go. Thank you, Ramya. Thank you so much. Yes, la la la. Great. Understood, everybody? Yes? Ma'am, this time which chapter in chemistry? This time, no, we are not going to go chapter wise. Yeah? We will do inorganic advanced 5 questions, okay? 5 questions from JEE advanced, and we will do mix up of all of it. Or let's see what chapter. Maybe we will do periodic properties first, hai na? Because we completed periodic properties first here also. So we will start with periodic properties for Fantastic 5. Does that make sense? Does that make sense? We will do that. Chalo, moving on, everybody. Conductivity. What do you think? Are they good conductor? Are they good conductor? Hey, we all know that these are. We all know that what are these? These are metals, and we all know that metals are normally good conductors of electricity and heat. So if they are metals, and plus we know that they have one charge which is loosely held, right? The valence electron is loosely held, of course, right? And that is why you can easily give it away. So because it is loosely held, that means it is mobile. It can move from one place to another, isn't it? It can move from one place to another very easily. So that means that they are going to be good conductor of heat and electricity. Easy? Easy, everybody? Shall we say easy peasy biryani is tasty? Yes? Shall we say that easy peasy biryani is tasty? How many of you are going to say that? Ma'am, 12th score is 55%. Might be a little tough. Learn by Tamil. I suggest that why don't you drop out, give the exam once again, score better in your 12th as well as in your JEE and NEET, okay? Density order some different. No, Uma, I'm so sorry. I actually said it ulta. See, what is written here, what happens is volume increases. As you go down the group, volume increases. But more than volume, mass increases. Yes, more than volume, mass increases. And you know that density is directly proportional to mass. If mass increases, density will also increase. But if volume increases, density decreases. But like I said, here predominant one is mass. Mass increases more. And because mass increases more, density also increases down the group. So from lithium to cesium, density increases. Okay. When will you explain periodic table? Geetika, periodic table was the first 2 sessions that I have taken in this channel. So please take a look at it, okay? I have already taken care of it, but if you want me to take you through it more, I will do that, but later, okay? Now you understood, Uma? Yes? Chaitanya, I'm so sorry, I will not be able to speak in Telugu, and this is not a Telugu channel, this is an English channel, okay? This is JEE English channel, so I have to speak in English. No other option, no other language, only English, okay? I'm so sorry, beta. Now, conductivity we have understood, everybody. Easy peasy biryani is tasty. Okay, now we're going to talk about flame test. Acha, tell me something. Color. You are seeing some color here, isn't it? Where does the color come? We have learnt about this in coordination compounds, that color always comes from unpaired electrons, and we know that these guys have 1 electron in the outermost shell, so we can understand that color will definitely come. Color will definitely come here. Yes. So what are the colors? Okay. Li. What can you remember from Li? I can remember lipstick and most of the time I use red lipstick, so for me this was very easy, right? For me this was very easy. Lipstick, crimson red. Li, crimson red. Sodium, golden yellow. Yes, violet, potassium will give you violet color, okay. Alright, rubidium gives you, rubidium, the word ruby is red color. So from there I know that rubidium is red violet color and cesium is blue in color, okay. Will this video be available? Yes, it will be forever and ever. I might die, but this video will not go anywhere. This video will be here only, okay. Yes. Doubt in F block, lanthanum is F block or not? Yes, lanthanum is F block, Purushottam. Lanthanum is F block. Yes, lanthanum is F block. Also, I have taken care of DNF block. Please watch the video. I have taken it. Alright, everybody, do we understand this, guys? Yes, flame test. They give you color in flame, okay. You get to see color in the flame. Why? De-excitation of electron. Very good, Anshupal. Very good. Yes. So what, Purushottam? So what? There are some exceptions. Please watch it. Watch the video. Please watch it. Alvin, that you can see. That you can say. Cesium is pronounced like cesium. C. So we know that C is blue color. Yes. C is blue, so blue color. So everybody, Li, I remember lipstick, and I most of the time I apply red lipstick, yeah. I try not to use any other lipstick. I most of the time use red lipstick. So I can remember that Li is what? Li is lipstick is crimson red. Crimson color is also red. Yes, crimson is basically another synonym of red, so we can say that red color, okay. Now coming to sodium, sodium is golden yellow color, K is violet, yes. Rubidium, again ruby is red, so we know that ruby is red violet and cesium is blue. So what do we know? Everybody just say it once again. Lithium is red, crimson red, sodium is blue, potassium K violet, yes, K violet, rubidium ruby red again, and cesium C blue, okay. Alright, good trick to remember, yes, that's how I remembered. Okay, now we're going to talk about photoelectric effect, okay. So we all know that atomic size of potassium, rubidium and cesium is actually quite large. So obviously their ionization energy is very low, right? Obviously their ionization energy is very low. Because their ionization energy is very low, you can understand that such low ionization energy, that from their valence shell electrons, the electron which is at the last shell, right, it can easily get excited and it will be like, okay, I got excited, but I can also come back. It'll come back, right? And the moment it gets excited, what will it do? It will absorb some visible light. Yes, it will absorb some visible light. And because it does absorb visible light, that's why you will see that they are used in photoelectric cells a lot. Thank you, Bala. Thank you so much. Yes. Is it? Yeah, it is. Learn by Tamil. You can drop out and you can learn. You can do it again. Yeah. So do we understand photoelectric effect also? So basically in this chapter, what is the godfather? That one term that is coming again and again. Like in D and F block, what was it? In D and F block, we kept learning about shielding effect. In here, do you see that ionization energy is very important here? Most of the things that you're talking about, ionization energy. What is the reason? Ionization energy. What is that reason? Ionization energy. Why does this happen? Ionization energy. Why does that happen? Ionization energy. So here the godfather is ionization energy. Learn this, bacha. In D and F block, your godfather is shielding effect. Yes, shielding effect. Here it is ionization energy. Okay, here it is ionization energy. All right. Yes, it is. Learn by Tamil. It is. I just told you, right? Now, standard oxidation potential. What is this? This actually you get to know it from only experiments, okay? You only get to know it from experiments. So, all the alkali metals, that is all the group 1 metals, they have high values of standard oxidation potential, yes? That means the tendency of releasing electrons in water is very high. Of course, they have one electron in the valence shell, so they can easily give away that. So the tendency is very high. They are always their tendency is, take it and go. Please take the electron and go. Yeah, please take the electron and go. Like these are philanthropists. They're very kind, very generous. Take it and go. They're doing that. Okay. So basically, what they do is they're also good reducing agent. Why are they good reducing agent? Yes. Why are they good reducing agent? Because they can give away electron, no Baba? They can give away electron, right? They're good reducing agent. So most of them, they have higher or higher positions in the electrochemical series. Okay, they have higher positions in the electrochemical series. Again, easy peasy biryani is tasty. Everybody, do we understand this? Easy peasy biryani is tasty. Do we understand this? Everybody, come on, write it down. Write down some la 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 in the chat box if you are understanding. Write down some la 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 in the chat box if you are understanding. Come on, guys, fatafat. Write down quickly. Chalo, chalo. Write down faster so that I can also move ahead. I can also move ahead. La la la. Yes, that makes me very happy. Okay, moving on. Now we come to chemical properties. But before chemical properties, shall we do the physical properties of group 2 also first? Let's do the group 2 one. Yes, Saransh, absolutely right. Lithium is the strongest reducing agent because of high hydration. Very good, very good. Thank you, referral and prediction. Shall we do the physical properties of group 2 and then we can come to chemical properties and everything will be, streamlined in your dimag, in your brain, basically. You tell me, what do you want to do? Do you want me to do chemical properties first or shall we go ahead and do the physical properties of group 2 as well and then come back do the chemical properties of both the groups and finish the class? Okay, ma'am. Okay. Then chalo. My wish. Huh? I will share. Today only I will share the PDF of the Telegram channel and then tomorrow you can go through the PDF and come to the class. Tomorrow we have class at 5 p.m. 5 p.m. we have class. Okay. 5 p.m. So then tomorrow you can go through it a little bit and then you can come. Okay. Then you can come. Chalo. Group 2. Let's start with group 2. Okay, group 2. Now what are group 2? Okay, this also I learnt it in Hindi and this is very famous. Beta mange car scooter baap razi. Okay, that means that son is asking for car scooter and dad agreed. Okay, can you remember it? Son asks for car scooter, dad agrees. Beta mange car scooter baap razi. Okay, this is how we know. Yes, this is how we know. Why is the density of potassium less than density of sodium? You tell me. You know the answer. You know the answer. You tell me. Why is density of potassium less than density of sodium? Because potassium is of a bigger size. Potassium is actually a much bigger size. Yes. And because of that, yes. And because of that, what happens? Because of that, the volume decreases. Because of that, what happens is, the volume has increased, no? Volume domination happens. So because the volume increases, density decreases. Not because of mass. This time it is because of volume. Okay? This time it is because of volume. Okay? Write that down. Yes. Again repeat. Son asks for car scooter. Dad agrees. Okay? In Hindi it is beta mange car scooter baap razi. This is what I know. In English, I'll have to find it out. Chalo, anyway. Now, these guys are called with love. What are they called? Alkaline earth metals. Okay. What do we call them? We call them alkaline earth metals. Okay. Now, why are they known as alkaline earth metals? Because A, they are alkaline in nature and B, on earth crust, you actually get these metals. Okay. On earth crust, you will actually get these metals. Beryllium is actually not known as alkaline earth metals. You know why? Because we have seen that most of the time, the first element in the group is always a little crazy, like, I'm not going to behave like everybody. This is what they do, right? This is what they do. Like even in my house, my mom and dad, I'm pretty sure, and I can proudly say this, I think my mom and dad loves me a little bit more because I'm the older one, right? And my brother is the younger one. So, if I show you the chat between me and my brother, I think most of the time he is just asking me, Didi, a little bit money please. And if I show you my Google Pay screenshot, if I show you the Google Pay this thing, you will see that every time I'm sending, but he will tell me in text, in WhatsApp, he will tell me, Didi, give me this much money, I will return it back to you. That day has not come yet. He has not returned the money yet. Till date only I am giving it to him. I'm like, yeah, take it. He asked for 5,000. I'm like, sure. 3,000 sure, 2,000 sure. So till now I'm only giving him the money, he has not returned it back. He tells me I'll give it back to you. So that's why I said, you know, my mom and dad, I think they love me a little more because I'm the older one, and let's face it, I'm more matured, yeah. I'm more matured. And why? And you know what? Whatever my mom cooks, till date, every time I go home, whatever my mom cooks, what am I doing? I'm like, oh, mama, this is very tasty, mama. Like, loved it. But my brother, you make dal today instead of chicken, he'll be like, I'm not eating. So you see, that's beryllium. That is beryllium. That is beryllium. Beryllium is the youngest one. Beryllium is on the top, and this will behave little crazy. It'll be like, no. Sorry, not molding into how you all act. So this is what happens, yeah. And that is why this is an exception. Most of the time you will find that the top one is always acting a little bit weird, okay? Just like my brother. Isn't it, Harini? I agree to you. He is your loving brother. Yeah, he is. I love him, of course. But that's why only I have the right to make fun of him, nobody else. Only I have the right to make fun of him, nobody else. Anyway, alright, moving on everybody. Focus up here, okay? Let's focus up here. So because they are also, they are so called because their oxides and hydroxides are again alkaline in nature, and these are found on Earth's crust, okay? These are found on Earth's crust, and that's why they are alkaline earth metals. This time they are not only alkali metals, they are alkaline earth metals. Agreed everybody? Let's talk about their general electronic configuration. What is their general electronic configuration? Because this time they have 2 electrons in the outermost shell, so it is Ns2, okay? Ns2. Now radium, the last one, that's radioactive again, so we are not going to talk about it much, yes. And okay, this is very important everyone, all of them are silvery white. Most of them have this color of silvery white. Yes, they have a silver color, and these metals are definitely harder than alkali metals. Now tell me, why are they harder? Why do you think their melting point and boiling point is also going to be slightly higher than the group 1 elements? Because this time they have 2 electrons, so they can form bonds which are a little bit stronger. Yes, they can form bonds that are little stronger than the previous group. Yes, and they are smaller than the group 1 elements. Yes, they are smaller than the group 1 elements because extra charge on nucleus. The nucleus also has more protons, so the nucleus can easily hold on to the electrons, and that is why they are slightly smaller, okay? They are slightly smaller. Good evening, good evening Naveen, okay? So the size increases gradually, of course, the size increases, down the group the size increases, beryllium, magnesium, calcium, strontium, barium, right? This is how the size increases, okay? Moving on, melting and boiling point, I just told you, because the metallic bond is stronger, yes, metallic bond is stronger, 2 electrons, my dear student, 2 electrons, metallic bond is stronger, and due to smaller atomic size and 2 electrons in the valence shell, the melting point and the boiling point is going to be slightly higher. It is going to be higher than the, what? Higher than the first group. Ketan, what is the number of beryllium? What number? What number? Are you asking about atomic number? Hi Anand Sharma, no problem, it's okay, no problem. Hi Indu, how are you bacha? Are you asking me about atomic number? You tell me what is the atomic number of beryllium bacha, you tell me. Hydrogen, helium, lithium, beryllium, you tell me. 4, exactly, 4. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4. 4 is the atomic number. So 2 in the K shell, 2 in L shell, okay? 2 in K shell, 2 in L shell. So 2 is the valence electrons, okay? Now, decreasing order of melting point and boiling point, you can see. Sorry, decreasing order of melting point is what? Magnesium, beryllium, barium, calcium, strontium. This is weird. Oh, sorry. For melting point, it is beryllium, calcium, strontium, barium, magnesium. And then again for boiling point, it is beryllium, barium, calcium, strontium, magnesium. Okay? This is how it is. This is how it is. Now let's talk about ionization energy, my dear student. Let's talk about ionization energy. What happened to ionization energy? Once again, this time it will be higher. This time it will be higher. The first ionization energy, remember I just spoke to you? The first ionization energy is going to be higher than group 1 because this time there are 2 electrons. This time there are 2 electrons. Yes, there are 2 electrons in the outermost shell. So obviously ionization energy 1, ionization IE1 is going to be higher, but IE2 is going to be very low. IE2 ionization energy 2 is going to be very low. Why? Why? Harini, I am also slightly confused. I have a feeling that that's wrong. Yeah, I have a feeling that this is wrong. Don't go for this. Don't go for this. We will talk about this a little later. Right now, I don't want to get confused in anymore. So let's skip this. I'll talk to you about this in some time. I'll talk to you about this in some time. Let me get back to this. Yes. How many lectures? 2. 2 lectures of this chapter. 2 lectures of this chapter. I'll just refer to my notes once and then I'll tell you, okay? I always have notes. Before I come to the class, I prepare and then I come. Anyway, alright, so the decreasing order of ionization energy, because size increases along the group. So obviously ionization energy will decrease, right? Ionization energy will decrease because size increases. It will be easier for us to take away the ionization energy. And once again, repeating myself, everybody do remember this. This may come, this is the trick here. Ionization energy 1 of group 2 is higher, but ionization energy 2 of group 2 is lower, because they can just get rid of that 1 electron and they can get their noble gas configuration. Yes, how many more minutes? 15 more minutes, everybody. 15 more minutes, okay? Now, this you have understood, everybody? Hey, why you guys are getting bored or what? You're not liking the session? Huh? Why you are all continuously asking me that, ma'am, ma'am, how much time? Purushottam, we will talk about that also, bacha, don't worry. Atomic weight is not very important. If you remember atomic number, most of the time, generally, atomic weight is double of atomic number, okay? There are exceptions, obviously. You will just have to remember the exceptions later. Can you take 18 group elements, Kishore? 18 group elements we have taken in P block. Watch that video, okay? Watch that video. Acha, oxidation state. Alkaline earth metal, what will they show, Baba? What will they show? What will they show? What do you think? What will be the oxidation state? 2 electrons. No? So obviously 2 electrons they will lose. 2 electrons they will lose. Correct? They'll be like, okay, 2 electrons, let's lose it. That's their plus 2 is the oxidation state. Very easy. Plus 2 is the oxidation state. Okay? Indu, we haven't reached there, yeah? We haven't reached to beryllium carbonate, okay? We haven't. So wait up. Wait up. Wait up. Let me reach there. Imagine this is a movie, no? When you go to a movie, do you ask Shah Rukh Khan to die right now only? If you know that, okay, you know that Shah Rukh Khan is going to die. So are you going to like forward, now Shah Rukh Khan dead, movie over, let's go. No, you don't do that, right? So imagine this is also a movie. Don't ask me to jump to the end right away. Yeah? Don't ask me to jump right away. Let me build up my story. Let me talk about it. Yes, let me talk about it. Pranay, you are not going to ask me such questions just like this. Please understand that I am following a storyline here. Okay, we are talking about group 2. We are not talking about thallium now. Please watch the proper videos for it. Okay. Yes. Thallium comes in which group? Watch that video. Alright. Yes. Okay. Chalo. Moving on everybody. Indu, once again, bacha, telling you the same thing. Haven't reached there. Please wait. You probably won't even have to ask that doubt, because the moment I reach there, I will definitely take care of it. So please wait up, okay? Once again, everybody, let's talk about electropositive or the metallic character. Yes, what is metallic character? Metallic character is basically, again, electropositivity. That means the tendency to lose away one electron and forming positive ion. What will they form? What will they form? They will form M2 plus ion. No? They can form M2 plus ion. M plus also they can form, but they can form M2 plus also, because they can lose 2 electrons, isn't it? They can form 2 loose electrons, isn't it? So understand this, that electropositivity is again inversely proportional to ionization energy. Ionization energy decreases, electropositivity increases. And because again the atomic size is smaller than the group 1 element, so obviously they are slightly less electropositive than group 1. Yes, thank you Bala, thank you so much. Yes. D block is available, bacha. F block is available. P block is available. S block is the last chapter I am taking, because S block was easier. That's why I took D block, F block, coordination compound, P block, periodic properties, and then I am coming to this. This is the easiest one, okay? This is the easiest one. Vx, yz, we will talk about it. Thank you. Don't worry about it. Meelu, thank you so much. Okay. Now, do we understand this? Also, electropositivity increases from beryllium to barium. Why? Barium has bigger size. Bigger size can easily get rid of their electrons. So, obviously, the electropositivity will increase. Now, coming to density. Density, what will happen to density? Density increases from beryllium to barium. And the increasing order of density is, I think it's wrong. I don't know. I think there is this conversion of slides to PPT has made these changes. This is wrong, huh? This is wrong. This is wrong. It's not like this. Density increases from beryllium to barium, so it is definitely Be less than magnesium less than calcium less than Sr less than Ba. This is the actual one. Okay, this is the actual one. This is wrong. Okay, this is wrong, everybody. Please make a note of it. Okay, this is wrong. See how it is increasing. In calcium there is a slight dip. In calcium there is a slight dip that you can see. Okay, in calcium there is, I'm cutting this down. Okay, don't go for this. Don't go for this. It's actually calcium first. Calcium is the lowest, then comes magnesium. Oh, this is right only then. This is right only. Let me erase it all. Sorry. sorry. This is right only. This is right. Although we generally say that from it increases from beryllium to barium, but we do not actually see it. Yes, we see that there is a dip in calcium. There is a dip in calcium. So, after calcium, there is magnesium, then it is beryllium. From beryllium, it is strontium, barium and radium. Okay, that's how the density increases. Yeah, I'm doing mistake. Yes. Now I have corrected. Okay. Yes, now I have made it correct. Okay. Yes. All right. Now I have made it correct. Got it? Yes. Chalo, moving on, everybody. Conductivity. What will happen to the conductivity? Aruna, did you understand? Had dinner? No, yeah. I have to finish the class and then go. Okay. No, I haven't had dinner. I'm also very hungry. Now is it correct? Everybody got it, no? Moving on. Yes. Got it, everybody? Yes, Somesh. What happened? Chalo. Conductivity. These are also good conductors of heat and electricity because they have two free electrons, right? They have two free electrons, and here is an exception. Normally we have seen that most of the things in group 2 are lesser than group 1, isn't it? Most of the time we have seen that most of the properties of group 2 are lesser than group 1, but here conductivity of group 1 is lesser than conductivity of group 2. Okay, I confused you, Kusheshwar. Chalo, let's move back. Density, everybody, we know that density increases top to bottom, but not however we want. Indu, stop spamming. Please stop spamming. I'm teaching you something. Wait up. I'm teaching you something. Learn that, bacha. Please learn that right now. Yeah. Wait up, please. Don't spam like this, no? Wait up. I'll tell you the answer. Indu, what am I telling you? I'm teaching you something. Understand, you are not the only student in the class. Please wait up. We will come to your doubt. Don't worry. We will come to your doubt. Yes. And you know that every time I take a class, I also take the most important questions of it, right? So it will come. Don't worry. Just give it some time, no? Just give it some time. Let me teach this. Density, bacha. Here it is written as density increases from beryllium to barium, but it actually does not happen like this. Actually what happens is calcium has the lowest density. Yes, calcium has the lowest density. Then there is magnesium, then there is beryllium, then there is strontium, then there is barium. Okay. Now do you understand, Kusheshwar? Have I explained this? Do you see it here? See, calcium has the lowest. It is only 1.55. Then comes magnesium, then comes beryllium. Then goes barium and then goes strontium, barium, radium. Okay, understood this? Everybody? Is this clear? Got it? Cool? Done? Understood. Okay. Conductivity also we have understood. No, flame test, what will happen to flame test? Understand. Because beryllium and magnesium, remember I told you beryllium will act a little crazy. Yes, beryllium always, the top one will always act a little crazy. So you see that beryllium and magnesium, they have a smaller size. Beryllium and magnesium have smaller size, and because they have smaller size, they're tightly bounded, they are not excited to higher level. The moment they try to go out, the nucleus will be like, where are you going? Come back. They will be pulled. So they will not give you any color, but calcium, Ca, calcium will give you brick red, strontium will give you crimson red, and barium will give you apple green. Okay. So brick red, crimson red, apple green. This is what you have to remember. Okay. Calcium, strontium, barium. Okay. So what do you know? Calcium, strontium, barium. What will it give you? Brick red, crimson red, apple green. This is it. That's it. Okay. That's it. Do we understand this, everybody? Yes. Do we understand this? Now coming back to, take a look at it. Do you see the anomaly? Do you see the exception here? See, beryllium and magnesium, they have smaller size. Ideally, what should happen in the density? What should happen to the density picture? Ideally, from beryllium to barium, it should increase. But why is this not happening? Because beryllium and magnesium have smaller size. Whereas in case of calcium, the size increases. Volume increases, density decreases. That is why calcium has the lowest density here. Understood, everybody? Yes. Now coming back to Indu's question. Indu, what was your question? Tell me. Now, Indu, what was your question? You were asking about the exception of calcium, right? You see what is the answer? Do you see what is the answer? Just explained it, Indu. Now, did you get your answer? You got your answer. I know, I think you have been timed out by someone. But chalo, koi baat nahi. I hope you understood this, okay? Photoelectric effect. These elements, they do not show this property as their atomic size is very small. Not very small, but their atomic size is smaller than the group 1, and that is why their ionization energy is also slightly higher. So photoelectric effect is not seen here. Okay, so photoelectric effect is not seen here. Coming to standard oxidation potential, everybody, let's take a look at it. Lower values of standard oxidation potential because of their high ionization energy. They have high ionization energy. From whom? Compared to group 1 elements, right? Compared to group 1 elements, they have high ionization energy, and that is why you will see that the standard oxidation potential has lower value. Again, increasing order of standard oxidation, see, beryllium to barium increases. beryllium to barium, it increases. But ma'am, lithium, sodium, very small size compared. What? Uma, no. Group 1 element has the biggest size. Apart from noble gases, group 1 is the biggest size in the periodic table. Beryllium and magnesium are smaller than lithium, sodium. Yeah, you are wrong then. Chalo, moving on. Now let's do chemical properties, okay? Let's do chemical properties of both the group. Chemical properties, okay. See, chemical properties is very easy. Okay. The first thing that we talk about when we talk about chemical properties is reactivity. Who reacts and how do they react, okay? How do they react? Now, we all know that lithium, sodium, potassium, rubidium, cesium, especially about lithium, sodium, potassium. Even in case of reactivity series, don't we know that they are very reactive? So, do you think that you will find them in free state? Impossible. Because the moment they are free, they are like, wow, air and oxygen, let's get reacted. They will do that, right? So it's impossible to find them in free state, and we know that again reactivity is also inversely proportional to ionization potential. And what is the order of reactivity? The size increases, reactivity also increases. So lithium, sodium, potassium, rubidium, cesium, that is the one, okay? NCERT lines later on. Right now let's try to finish the concept, and also since this is JEE channel, I don't think we need NCERT lines line by line any longer, because let's face it, that's more important for NEET and not for JEE, okay? JEE has more advanced kind of questions, so we will do that rather than doing NCERT line by line, okay? Alright everyone, do we understand this, guys? Reactivity we have understood. Now coming back to reaction with air. Mostly, what is it present in air? What is the composition of atmosphere? We all know that in atmosphere, the composition of nitrogen is very high and oxygen is the second most abundant gas in atmosphere. Rest all of these trace gases, carbon dioxide and blah 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 is like, you know, there, somewhere there. But we know that nitrogen is 78% and oxygen is 21%, right? That's what we know. So that means that we are going to talk about reaction with air. That means oxygen and nitrogen. So alkali metals, what happens is they tarnish. Tarnish means what? So we know that metals have a property that they are always lustrous, they are always shiny, and that's why we use them in jewelries and everything, isn't it? But this time, the moment you keep them outside, they react with oxygen and they tarnish, they are lustrous, yes, they are the shininess that goes away, that fades away. Yes, because they form oxide, a layer of oxide is formed, and that is why they lose their shininess, okay, they lose their shininess. Also, you understand that sodium, potassium, lithium, right? Yes, especially lithium. Lithium is also very lightweighted. Lithium is also very lightweighted, right? So if you keep lithium in kerosene, what will happen? Lithium will be like, it will come, it will float on top of it and it will come up, right? And if it comes on top, then what will happen? Again it will react with oxygen, again it will get tarnished, so that's not possible. So where do you keep them? You keep them in paraffin wax, so that it cannot just like, you know, come up and like, okay, I will react with oxygen, I will react with nitrogen. It can't do that, okay? So you keep it in paraffin wax. Understood, everybody? Yes. Now let's talk about these elements. How do they react with moisture? So all this time we were talking about dry air. Dry air, okay? Dry air, no moisture, completely dry air. Now we are going to talk about what? Moist air. So if you give them moist air, yes, sodium will react with oxygen, and of course there is a little bit of moisture. Remind you, there is a little bit of moisture. So if there is moisture, that means H2O, little bit of water vapor, little bit of moist. So of course it will form hydroxide. It will form hydroxide. Yes. One more thing, everybody. One more thing that you have to remember is this lithium, sodium, rubidium, potassium, rubidium, cesium. Okay. What do they form is? Okay, remember this, remember this. Lithium reacts with oxygen and forms oxide. Okay. Lithium reacts with oxygen, forms oxide. Potassium, sodium. Sodium, potassium will react with oxide and they will form peroxide. Okay. Alright. Now, lithium, sodium, potassium, rubidium, cesium. No, potassium, rubidium, cesium. Potassium, rubidium, cesium will form superoxide. What will it form? Superoxide. Oxide, peroxide, superoxide. Oxide, peroxide, superoxide. Lithium, oxide, sodium, peroxide. Rest all the three, they will form superoxide. That's how you have to remember, okay? That's how you have to remember. OPS, OPS, oxide, peroxide, superoxide. Oxide, peroxide, superoxide. Got it? Everybody, this is their reaction, okay? This is the reaction with moist air. Got it? Yes. In dry air, only lithium can give you nitride and oxide both, whereas all the other elements, they don't even react, okay? The other elements, they don't even have to react. Are you getting it? Are you getting it? See, what did I tell you? Oxide, peroxide, superoxide. Lithium will give you oxide, only forms monooxide. Sodium will form peroxide, whereas potassium, rubidium, cesium, it will form superoxide. Yes? Got it? Cool. Moving on then. Ma'am, if will you teach inorganic and physical chemistry in NEET Elite channel? I don't think so. I'll be teaching only here. I think I'll be teaching only here. It's not very affordable for a teacher to, not affordable, I would say. It's not very easy for a teacher to be in 2 to 3 channels, right? And I'm already in 2 channels. It'll be very tough for me to be in another channel. So we will see, okay? We will see. You can't find coordination compound. I've taught you. Live pe jao. Go to the live tab and there find it. Alright, now what is the stability of different oxides of a metal, right, due to its lattice energy. So normal oxide will be higher, then will be peroxide, and then will be superoxide, okay. Reaction with hydrogen. Alkali metal, they react with dihydrogen at about a high temperature, 673 Kelvin. You don't have to remember what is the temperature. Just remember that it is at a high temperature, okay. And for lithium, because size is smaller, right? Lithium has a smaller size, so lithium will need even higher energy. Lithium will need even higher energy, okay. So lithium needs 1073 Kelvin, rest all of them need 673 Kelvin, and all of them, what do they give you? They give you metal hydride. What do they give you? They give you metal hydride. Do we understand? Do we understand, everybody? Yes, got it? Cool? Alright, moving on then. Hydrides of alkali metal, now they are attacked by water to give hydrogen. They form hydrides, but hydrides are not safe. They are attacked by water. Water will be like, you know what, I want my hydrogen gas. I want my hydrogen back. So what will happen is, metal hydride, it will react with water, it will form metal hydroxide and it will form hydrogen gas. Obviously, if it is forming metal hydroxide, don't you think that hydrogen gas will have to be liberated? Where will the other hydrogen gas go? Where will the other hydrogen go? It will have to be released, no? So it is releasing here. It is getting released here. Yes? And what is the thermal stability? Basic property. What will happen to that? See, thermal stability decreases, basic property increases. Okay? From lithium to cesium, thermal stability decreases, basic property increases. Do we understand this? Do we understand this, everybody? Metal extracted from sea? Huh? Where? Suddenly, where did you get that idea from? Anyway, reaction with water. Will you upload videos? No, Kartika, I don't think so. Right now, I'm teaching here only. I only know about this. I don't know what will happen there, okay? Yes. Will there be? Yes, Akash. Yes, there will be. Okay, there will be. Don't worry. Now, alkali metals, they react vigorously with water. Again, this is something that we have read in lower grades, Baba. Hai na? We know that sodium, potassium, just put them in water, they will burn. Fire, they will say, right? Yes, they will say fire and they will burn. Correct? I mean, we use the most common fire extinguisher probably is water, but these fellows, they're super crazy. Yeah? You put them in water, they'll be like, you know what, I'll give you fire. How will you extinguish me? I'll give you fire. They will produce fire. Yes, they will produce fire, isn't it? So we know that alkali metal, when they react with water, they will give you metal hydroxide and the same reaction, hydrogen gas. They'll give you hydrogen gas, isn't it? Clear, everybody? Now, lithium is slightly less reactive towards water, but sodium and potassium, they react vigorously, okay? They react vigorously. And rubidium and cesium also react explosively, like boom! That's how they will go, okay? That's how they will go. Monooxides, they give strongly alkaline solution with water, as you can see, monooxides. Remember, oxide, peroxide, superoxide. So the monooxide will give you a strong alkaline solution with water. Yes, easy peasy biryani is tasty, everybody. Easy peasy biryani is tasty. MBG Ashok, I'm not very sure about it. I'll have to find it out and then tell you, okay? I'll find it out and then tell you. Chalo, now reaction with halogen. What is halogen? Halogen is fluorine, chlorine, bromine, iodine, all of that, astatine, right? That's your halogen. Yes, halogen. Yes, what do they form? They will form halide. What will they form? They will form halide. So metal, when they react X, X is what? X is fluorine, chlorine, bromine, iodine, astatine, all of that. Not about astatine, but we are talking about majorly about fluorine, chlorine, bromine, iodine. So fluorine, chlorine, bromine, iodine, X2. What will they form? They will form 2MX. So ionic nature of MX increases from LiCl to, okay, so Li, lithium is small size. Small size, what will it form? Covalent bond. But rest of the other elements, what will they form? They will form covalent. They will form, they will form ionic, okay. Their bonds will be ionic, but LiCl will be covalent because A, due to polarization of Cl minus ion by the small Li plus ion, and the tendency of hydrolysis is more. Fr is not, no, Fr is francium is more of radioactive. That's why we don't talk about it so much, okay. That's why we don't talk about it so much, alright. Reaction with nitrogen. Nitrogen we are already done with. We know that lithium will give you nitrite. Rest all of them, they won't even do that, okay. Lithium will react with nitrite, which gives NH3 on reacting with water. Rest all of them, they won't even react, okay. Finally, last thing, bacha log, let's talk about formation of amalgam. What do we know about amalgam? Amalgam is basically when they mix up with mercury. Mixing up with mercury is called as amalgam. So these metals, they react with other metals to give you mixed metals, okay. Mixed metals they will give you, and they give you also alkali with Hg. And finally, one last thing, everybody, solubility in liquid ammonia. All the alkali metals, they dissolve in NH3 liquid. They dissolve in NH3 liquid. And write this down. Write this down. This is what they form. MNH3 X ENH3. The electron that they are releasing, that is also, see, that is also with ammonia. Ammonia tries to basically engulf everything and make them dissolve, okay? Ammonia tries to do that, alright? Now take a note, this dilute solution is paramagnetic in nature. And by any chance, if you take NH3 in excess, do you know what will happen? You will get diamagnetic. And the blue color and reducing nature of solution is all because of this ammoniated electron. This is your ammoniated electron, okay? So guys, I think I will stop here because today I also have to go somewhere. It is my niece's first birthday. She is 1 year old. I have to go there. It's very far. So I'm going to stop here today. In the next session, that is tomorrow at 5 p.m. I want to see you all. Please tomorrow come at 5 p.m. and we will discuss all the other remaining things, okay? Yes. Yes, bacha, yes. Thank you so much everybody. With this note, I will be stopping today's class. I shall see you in the next session, that is tomorrow 5 p.m. Please do come, don't miss it. Tomorrow 5 p.m. we are going to do other compounds and their characteristic, and we will also do group 2 chemical reactions, okay? Chalo, see ya all everybody. Lots of love. Do study this once, okay? Bye. See you all guys. Yes, thank you so much. Where is the